Good evening, everyone. Today, I am Anas Jas of Civil Section S4 is going to present about Bitcoin blockchain, how the system works, is this even secure, is this a global scam, or is it just a better database? So, shall we start? So, currently in the situation, we have so much of liquid cash, so much of money in the form of cash, the liquid money, or in the form of stocks stored in banks, all that thing. Uh, you can buy gold stocks. You can store your money in forms. And as of now in India, there are trillions of cash flowing, which is being circulated, and we both know that more than that is going under the table, and we don't even know that how legit is it, who is transferring it to whom. We don't even record. Is no one is recording it. We cannot track it. To make it even worse, sometimes governments are even involved in this process of counterfeiting currency and uh, saving the big players. And uh, as a common man, the common public cannot do anything about it. It's too centralized. We are too dependent on the system, a third-party system. So there are some serious issues related to the current system of transaction. Some of it is a centralization. Currently, banks and government hold all the individual assets, and so the government and the bank controls how the money flows. That poses a greater threat. If say anyone in the system, if anything goes down, anyone in the system goes down, it takes a thousands and thousands of cash of common man, the people with them, and there is no way to know about it. If, say, the bank XYZ meets a failure, all of its money stored in the bank will go down, and you cannot do anything about it. You're just helpless to trust them. You have to trust them because there's no other way to secure your money. And moreover, you cannot transfer your money like any commodity. You cannot attach your money to like an email and send it to your friend. It's not even possible to share your money like that. You have to go through a third party system like a bank to proceed with this transaction. You cannot do it yourself. You have to trust someone else in the part of the process. Which brings us to the second point, the opaqueness of the system, like black money, the illegal currency which flows under the table. There are like there is no way to know how much black money is currently in the system. Uh, Recently, many high-profile cases made to the headlines where the banks, the NPAs, the banks part the NPA, the non-performing assets, and it's not even clear if is the government is helping them behind the scenes, and is it even legit. Like you cannot track who send the money to whom, and like it's not even recorded. The third point is the threat. like uh, Say, what if uh, a bandit comes in and loots a bank? What will happen? Simply, all of your money is gone. You're depending on them. You have to trust them on their security. You cannot build your own secure. You cannot secure that your money. You have to trust your money to them. Uh, if the same way, like if a government hold your identity, say Aadhaar card or anything related to identity, if it comes under attack, there is no way to of you to actually prevent that. It's completely up to the government how it prevents the attack, and if it fails, you fails too. And this is really a gruesome situation. Like, you cannot do anything about it. Is there a solution? Yes, there exists a solution. It's called blockchain. The blockchain system. Uh, the blockchain. In blockchain, the system of distributed ledger, this decentralization of the money refers to control and decision making from a centralized entity like a bank, organization, individual, to a distributed rather, shifting from centralized to a decentralized network. It reduces the level of trust. That means you don't have to trust anybody to process a transaction. You can just don't have to. You just have you and the third. You and the sender and the receiver have to come to a mutual agreement between the transaction, and that's it. You only two of the party need to be agreed on this transaction. Not any third party need to agree to this uh, transaction. Like this frees you from the third party, and uh, the third party cannot deny your transaction. It cannot it have to just validate your transaction. It don't have the authority, or the authority is between the sender and the receiver. The transparency of the system lies in the fact that every transaction is recorded, and it is immutable. You cannot change it. Once it's recorded, it's done. It's done for good. Everyone, it the transparency of blockchains lies in the fact that everyone have a copy of the same blockchain, and everyone knows what transaction is there. Like, you can trace a transaction to its original owner. Doesn't matter it was years ago the transactions were made. You can just reach to the original owner of that value of that bitcoin, of that uh, asset you're transferring online. Security of the blockchain is the biggest factor of it. The blocks are encrypted using the SHA-256 algorithm. The proof of works ensures a secure system. Uh, the The SHA-256 algorithm is a very tight encryption algorithm. It comes with the 2 to the power 256 combinations. You can, like, not even supercomputers in the 1,000 years can break this encryption. And even the due to the size of the Bitcoin network and how fast it is growing, the cost to pull off a hack into network feed would probably be insurmountable. Not only would miss this extremely expensive, but it would also likely be fruitless. You will waste all your resources, all your money in validating, in making the transaction illegal or making it invalid. But in the end, someone else in the network will validate it, and your transaction will be discarded. This will just cost you money for the computational power, and it won't result in anything. The blockchain is a long chain, it's immutable, which cannot be altered. Once a block is entered into the blockchain, it cannot be edited. Once everyone, 51% of the miners agree to adding a block, the block cannot be changed by a single person. It's very high, and it's highly unlikely that any person or any organization owes the 51% of the computational power of the earth. So it makes it very secure to use blockchain and transact and give a transaction using blockchain. The history. Before starting the discussion on blockchain, how it's actually work, first of all, let's talk about a little about how blockchain and Bitcoin was developed. Well, the blockchain was first described by the Stuart Haber and W. Scott Stornita, and a document in timestamping a document. The timestamp stamping of document using a hash algorithm. Back then, the patent of this technology was lapsed in 2004 because it didn't find any use. So, how did it all start? Well, remember the financial crisis of 2007 and 2008, the Great Depression? People were losing their valuable money, their valuable assets, and in the banks were busy getting the bailouts from government. Governments were trying to revive the economy by bailing out bailing out loans to the banks, uh, uh, and we don't even know that those bailouts were even legit. Like if the bank is uh, gone for really is gone. Enter Satoshi Nakamoto, a group of person using the name Satoshi Nakamoto in 2008 to serve as the public transaction released a white paper underlying the fact how blockchain networks works. We don't even know who this guy is, Satoshi Nakamoto. This guy don't hold an identity. And as far it is concerned, we only know about the fact that this is some anonymous person or group of anonymous people who made this possible to create a blockchain transaction. That's how a blockchain came into existence. But surely he had a great reason for creating a blockchain network. Because the first of the blocks the Satoshi Nakamoto released on his forum uh, were timestamped with a message, and I quote, "Chancellor on brink of second bailout of banks," unquote. So this guy was clearly upset about how banks were being bailed out by the government, and the normal men were losing their money. Uh, So he developed a decentralized system of transaction. He solved the problem of double spending, which prevented many early stages systems like Bitcoin, other systems like Bitcoin, which came like in 1990s or like in 2000. Uh, so let's before proceeding and understand how actually the blockchain system work, we need to understand some of the terminologies. The first of one is P2P connection. Well, the P2P connection is stands for peer-to-peer connection. Isn't like the standard client-server model. It don't include the central authority which validates your request. It involves every peer, like every system available on the network is connected to every other system, and it can communicate directly. Don't require a centralized system, a centralized server. It is independent of the central server or the central authority. Exactly what we need for the blockchain. The second thing is SHA-256. The encryption, the strong developed by NSA, which made it possible to encrypt and check the integrity of a data uh, uh, by running it through a complex computational irreversible uh, program algorithm which will convert a text of information or even files, gigabits of files, to a fixed number of 256 bits, that is 64 letters cipher, which is unique and which is very unique, and even a slight information change, like even the slight information, like if this the in this example, the hello world, if I remove this space, this hash will completely change. This won't even, you can't even, but it will be same every time, and every system of this in this world, but that hash will be very different. You cannot even have a guess, like it's so much different. You can even put big files to algorithm, the encryption algorithm, to create this. Actually, this string is wrong. This should be a 64 digits is long, and this is actually wrong. This is something a different will be created, a 64 digits long string. There were many other encryption algorithms like MD5 and Bcrypt, but SHA-256 is one of the strongest player, and it encrypts the data uh, to really uh, amazing, really, like the collisions are minimum in the SHA-256 algorithm. You don't have a same data for two different same string hash string for two different data. And hashing is a type of special type of encryption. It's irreversible. You cannot reverse it. Once it's converted to this string, you cannot decode it to this string. You cannot even guess the that this is this string is this data. You have to check the if it is the same string. You have to run this data to this again to the same algorithm, and will match the hash string to find that it is the same data. Next, we need to discuss the transferring of files in the public and the private keys. Well, it's a very secure way of asymmetric encryption using the sender. The sender and the receiver have two keys: the public keys and the private keys. The both of them have a different public key, which is basically their address to receive the file, just like your bank account number, and a private key, which is like the password. If you want to send a file to the receiver, you have to first encrypt the file using the receiver's public key, and the encrypted message can only and only be decoded using the private key of the receivers. So once the receivers receive the so this is how the public asymmetric encryption works. So let's get to the next topic: block. What are blocks? How transactions are stored? There exists a long chain of blocks out in the world. Every miner or any person can obtain a copy of. And given a point of time, their copy will exactly match with each other. Blocks are files where data pertaining to the Bitcoin network are permanently recorded. A blocks records some of the most recent Bitcoin transactions that have not yet entered or prior blocks. Thus, a block is like a page of a ledger or a record book. You can it contains the data of the transaction, like the person A give $10 to person B, or say a person C gives 10 bitcoins to a person D. uh, Once and the next block is only added to the blockchain once a block is validated and enter into the blockchain. So the block have the following properties: a previous block hash, a transaction, and a nonce. Previous block hash is the address of the previous block it is referring to. The transaction is the data which the block contains, and a nonce is a special string, hash string we will talk about in just in a minute. And all this data will be hashed to create a unique hash for that block. So if so, remember the fact that even a slight change in the data can produce a very different hash. So if a previous block hash, the transaction, the nonce, even single of m is changed, the hash of the block is changed differently, and it does not it invalidates the valid block. It just not invalidate the valid block. It invalidates everything after the this every block after this block, because the next block to it will contain a previous block hash, and this previous block hash has changed. The previous block hash and the this thing, the hash, and the in changing any of this will change this, and this next block previous block hash will be different from the new calculated hash. So, a nonce. What is a nonce? Nonce is an abbreviation for number only used once, which in context of a miner is a hashed or encrypted string. So, so let's see how actually the blockchain process work to validate a payment. So, user one initiates a transaction of encrypted using the receiver's public key, which can only be opened or signed using the receiver's private key. Once the receiver uses its private key to sign the transaction, the initial transaction, but before this process, the initial transaction is validated, so that the sender needs to have a needs to really to have the amount available to proceed the transaction. Like if you want to send the 10 bitcoins to the receiver, he needs to have 10 bitcoins. Without this, the transaction will be invalid. Once the receivers sign the transaction is added to a transaction to this blue pool, which contains many other transactions, and the race begins. Uh, so the race begins. The Bitcoin network decides a hash, the target value by which the hash should be smaller. The calculated hash of the block should be smaller. And as you remember, the block hash can be altered using the nonce previous block hash transaction. So the miners will manipulate the nonce by putting manually or by the computer value by value 1, 2, 3 to change the hash to meet a criteria of the target set by the Bitcoin network. The billions of miners indulge in a race to validate the transaction, and the one lucky miner will actually find that value which is smaller than the hash. Look at the below value. This green value is smaller than the target hash. Once uh, it is found, and it's totally random. You cannot like for the value 21, say the hash produced is just one digit greater than that, then the 20 won't give the desired value. maybe the result will be found in 3,30,000 of what. It's completely random. You cannot guess, and you cannot even reverse engineer the process. You have to go through the process to find the correct hash, the correct smaller hash. And once the transaction is validated, the block will be valid and will be added to the uh, the blockchain, and it will be solidified. It will be mutable. It cannot. No one can change the block. But this is and what does the miner have in this? The miner computes the mathematically computational expensive problem. uh, so the miners get 12.5 Bitcoin as a reward to mine the block to validate the process. So the miners are the security of the sole security of the blockchain network. So how secure is this system is? Well, you cannot make invalid transaction because you need to have money first to in Bitcoin wallet to actually transact it to someone else. The second rule of the blockchain is the longer the blockchain is, the more the proof of the more computational power with the blockchain is created, it is more accurate, and it will be considered more accurate. So, say if a miner is fraudulent and by chance, by luck, he validates the transaction, he and changes the validation, the data inside the block. If he do so, he add the block to the blockchain. But as the process goes on, other miners will also start doing the validation process. And once 51% of the people are actually sending another blockchain, and one guy is sending another blockchain, the majority will be considered. This is called the consensus algorithm, and the lower one will be rejected, and the bigger blockchain will be included and will be held correctly. So the miner won't get anything in return. He will just waste his computational power to solve a complex algorithm, which won't give him the Bitcoin and the reward. So it's very computationally expensive to do such frauds, and it will be sometime in the future will be invalidated by other Bitcoin and other miners. So let's see the applications. The applications of the blockchain is a Bitcoin. Well, a Bitcoin have we have saw that a Bitcoin is traceable, can't be hidden and can't be changed. We can trace exactly where the Bitcoins is spent and where the Bitcoins are coming from. So the banks and the government can't do frauds, and the people using the black money can't go unnoticed under the system. The second application is voting. In the most basic form, blockchains are digital ledger. So using that, the voting can be very well be conducted using the blockchain system, and it will be very secure and won't be can't be edited or changed by anyone. So voting fraudulence are reduced to zero. As we know that the uh, blockchains blocks are traceable by nature, as they includes a previous hash, and the previous block will also have a previous hash. You can actually, while uh, logistic while performing logistics, you can exactly pinpoint where the your item is in the network, and where it has it don't need a third party system to actually trace the logistic. There are although some limitations to Bitcoin. Let's have a look at them. First of all, is users are their own bank, so their security is their responsibility. If he/she loses the private keys to the Bitcoin he owns, he is gone for good. All the money he owns will be gone, and a hacker can hack into the Bitcoin wallet and takes all his money. The second is non-eco-friendly. Well, the computational expenditure of the calculation of a such large hash encryption are so non-eco-friendly. It takes so much energy, so much electrical energy, that uh, uh, the high energy consumption is very bad to the environment. Blockchain cannot go back. Data is immutable. So your privacy is your the blockchains eliminate the idea of privacy. You cannot edit the blockchain. So this you cannot edit the blockchain if what's written in the blockchain is written. So if you want to change anything in the blockchain, you cannot. The last and the most critical disadvantage is it's a fairly new technology. We don't know the exact use cases of the technology. Although the blockchain is sounding very trustworthy, this is fairly too early to trust a technology like this. So, is it the future? The scam? Well, Citibank noted that the Bitcoin futures is still very uncertain, but it's on the cusp of a mainstream acceptance. The institutional investor interest is driving board interest in the cryptocurrency, but issues over custody security and the capital efficiency are still headwinds for the digital assets, noted Citi. So, it is fairly too early to call it the future or the scam. Thank you very much. By this, I conclude my PPT, and thank you very much to patiently listen to my work.